So hi, my name is Eldad. I try to solve problems at JFrog as an architect. I'm a developer turned into an infrastructure geek years ago, more than 15 years ago, and I've been doing CI, CD, CM, if anyone knows, ALM, CVS, and all the others for quite some time. And I assume you know Docker, I assume you know Kubernetes because you're in the right conference for that. And I want to share with you some details from our journey into Kubernetes, some things that we've learned. I'm sure that many of you will have some more things to share, but this is just for getting started and trying to share our pain, because end of the day, I think no one will argue Kubernetes is hard. So why did we even go into this journey? We had some urgent things that we had on our table, and they were pushing us towards finding solutions. So with the problems we needed, a running environment, and we need it now. I'm a developer on a branch at a product, and I need an integration environment with another product and their development branch. We wanted to better utilize our resources instead of just spinning up a VM for a small process. We wanted to be able to use the same resources for multiple services. We recognized that the market is going towards Kubernetes, and we wanted to be able to provide our customers with distributions that can run in Kubernetes. And we wanted to find the best way to take our containerized application and run them in Kubernetes. This gives you a graph of the real big problem that we have. How do multiple developers on multiple branches in multiple products integrate together? And this is one of the problems that we had. Setting up such an environment could take up to hours at that time. I think everyone is aware of this challenge. Your containerized app is really nice when you run it locally with a Docker run. But when you need to take it to production, there are multiple challenges and things that you need to take care of to actually make it work. It's just not another Docker run on production. So let's just skip to the end. Okay, after this, you're welcome to leave. I'll stay with anyone who wants to hear more details. Start small. Get the application ready before you dive into Kubernetes. Security. Control what's in your application, what's in your containers. Put the limits, use the health probes, have to have good visibility, monitoring, logging, debugging, and work with the community. Anyone want to leave? Okay. So this is how we started. When I started, I was given the task of trying it out about 3 years ago. So I was going through some blogs, seeing some videos, and this is what I figured. This is Kubernetes. It's going to be pure bliss. The reality is that it looks like this. And it took me a while to figure it out, because I was looking for that blue sky. Everything I was looking for was blue skies and green grasses. So where should I start? Start small. I was in a hurry to try and get our applications running in Kubernetes. I just crammed them into container, just started running them, and my nodes just kept crashing on me because I didn't really know what I was doing. There are a million demos out there. Use them. They're good to get a feel, to understand the internals and externals of using Kubernetes. Try to set a minimal goal, step by step. Let's just try and deploy. See that the container actually starts up. The pod is actually responding. And get comfortable before you move on. Starting with local Kubernetes like Minikube or Kubernetes and Docker. Both are wonderful tools, very easy to get your local Kubernetes running and useful. And then you can move up to manage Kubernetes. Try and isolate or differentiate between the need to actually run and manage Kubernetes and deploy your applications in Kubernetes. Long before jumping into Kubernetes, you have to realize and understand that the biggest challenge is actually getting your application ready. Because most companies, especially companies like us, we had applications running long before Kubernetes existed, and long before containers that existed. And taking our applications and making them work properly in containers and then in Kubernetes was quite a task. Thinking of logging. Where do I put the logs? Do I use log files? What about multiple log files? Do I need to persist this part of the application, or is this part of the configuration that's supposed to be managed by Kubernetes? Handling of termination signals, something that you don't really think about. What happens if the container, the pod crashes, or is sent a termination signal? Does my application know how to handle it properly? How do you survive a restart? If I initiate a restart, does my application start up properly? Does it pick up from where it stopped? Is there any corruption of the information? High availability. You always want to strive and have multiple replicas of your application, of your service running. It gives you resiliency, it gives you durability, things that are now fairly easy to get them working in Kubernetes, but you have to keep that in mind. It allows you for scaling up and down, automatic, horizontal pod autoscaling. You can roll upgrades with zero downtime. That's a great pro. If something happens to your cluster, and something will happen to your cluster, nodes always fail. It's just a matter of time. Or you want to upgrade your cluster. So you want to roll the upgrade on the cluster. You still want to keep the application ready for service at any given time. If you're not familiar with the 12-factor app, that's a great resource. It's a very short read that helps you figure out if you are ready or not ready to run in the cloud-native containerized environment. Just go ahead and read it. It's fairly easy reading, doesn't need any formal education for it. It's just a lot of common sense. And many of the rules applied here are relevant to your applications, old applications, new applications. Let's talk about security. Your application is never the only thing in your container. You have some open source libraries, you have some operating system libraries installed there, so they're all running together. Are you secure? Are you sure you don't have any vulnerabilities? Are you not exposing any endpoint that malicious code can use to hack your system or cause you any damage? A large number of public Docker images are known to have critical security vulnerabilities. Just look for it online for reports. Many companies have created these reports, have went through and tested public Docker images of well-known products, not something benign or a niche product. And if you use them, you should be aware and very careful not to expose yourself. Another thing that is commonly and often overlooked is open source licenses. If you're familiar with the thing that there's some licenses that are open source, but if you pack them with your application, that you might be liable to some legal implications. And now let's talk about Kubernetes. So Kubernetes, what is it really? It helps us to solve some problems. It helps me orchestrate my containers, helps me manage the applications, the containerized applications, helps me with managing the thing I showed you before. It gives me a lot of these as a service, which is a wonderful thing. And it gives me a single endpoint or a single API. I can talk a clear language that completely abstracts the infrastructure from me. What do we at JFrog do with Kubernetes today, or the journey that we've been talking about? All of our CI/CD goes through Kubernetes. We run the builds there. We deploy our test environments, our integration environments. We have a single Jenkins job that a one-click will set up all or some of the products for you, either co-located or geographically distributed. We have hundreds of environments set up every week, and it's tied up very strongly into our existing automation. So when a push is being done to one of the branches of a product, a full pipeline is being run, and part of that pipeline is deploying to Kubernetes, testing what we consider as the quality gates, and then releasing if possible. And we've also published official Helm charts for our products. We use the same charts, by the way, for our production cloud-based deployments. If you're customers of our products on the cloud, you'll be happy to know that most of them, if not all, are running today on Kubernetes. Limits, always limit your pods. And that is something that I think most of us know, but you should always be aware that sometimes you also need to limit the application running in the pod. I assume, or I hope some of you have stumbled on the simple case that Java up to a certain version was not aware of the container limits. So you also had to restrict Java in the same limits that you restrict your pod. RabbitMQ, the same, had its restrictions. I had some initial RabbitMQ deployments. We forgot to set the memory limit, and you just saw the whole node's memory, and it's consumed it. And that was one of the reasons our nodes crashed. MongoDB, same. These things have improved, and the application developers of these products and other products are now much more aware of the containerized environment and Kubernetes in particular, but it's something that you have to be very aware of, because if you're not, then you are exposing yourself to some serious resource abuse. On the other hand, you should also be aware that although you can over-provision your cluster, when the load starts up, you can find yourself bouncing pods in and out and getting many pods evicted. So don't over-provision. We've seen cases where either our developers, I did it myself, said, OK, I can deploy 100 Artifactories on one node. It doesn't work. It gets too crowded, and as soon as some load is being seen on any of the services, it crashes. And then you don't really realize, why did it crash? There are multiple ways to manage the resources, and you can also use the pod priority and preemption, which also helps you give control. Who's more important? Who do I less care if it crashes? Application health. The probes that Kubernetes helps you utilize, the readiness probe and the health probe, the readiness and the liveness probes are very important to really know if your application is OK. Because using these, you can apply auto-healing, which usually means it restarts your container. And believe me, it saves a lot of phone calls at 3 a.m. We've been there, we are still there, but it has improved dramatically just because an automatic restart was able to pull us to the morning. 3 types of probes. You can see that later. Multiple containers in the pod. There are many use cases where multiple containers in the pod make perfect sense, like init containers to set up your environment or set up credentials. The init container will go to your secret manager, pull in something, and then you're able to set up the environment. Collecting the logs. In our applications, we have multiple log files, and we can't push everything to the STD out. So we have log files, and we offer or suggest how you can use FluentBit or any other log collector to collect these logs and then forward them to Elasticsearch or something like that. Applications lifecycle. So you have a lifecycle to your application. You have versions. You have the versions of the third-party components making up your application. You have to be aware of that, and you need to be able to manage it. You want the ability also to roll back if you have a bad deployment. Having all configuration in YAML files is great, but how do I differentiate between different environments? If you remember before, I said we have Helm charts that we use for the same environments, for our development environments and for our production environments. So how do we differentiate that? We do that with Helm. We found that Helm is the best way to manage our deployments in Kubernetes, and I think after looking in multiple solutions, that was the one we felt most comfortable with. And I don't say it's the only solution. There are great solutions out there. Helm 3 coming out now is also a major improvement towards a great way to manage your deployments and your application's configuration as code. It describes the whole application in a single package. Many times your application is made up of multiple parts, multiple services, third parties. So you declare it in one package. It's very convenient and helps you get a good control and good understanding of what's there. You have the default the configuration file, the values YAML, and you can override that with different environments. Like in this example, it's hard to see, we provide suggested values for a large instance or a medium instance or a small instance inside the Helm chart itself. So you're able to look at it, and since it's open on GitHub, you can always have a look and see. We use the same chart for all of our environments, and we use different value files for each environment. The developers will use the default values, and that's set up like that so they don't have to care about it. I just want to spin up one of the applications locally on my laptop to test something. I don't really need to care. Do I need this YAML or the other YAML? Just a simple Helm install. And managing the external charts, the third parties like databases or secret managers or any other tools that you need as part of your application as requirements, as dependencies, Helm is very convenient and very practical. Some commands that are very useful in managing the Helm lifecycle and the Helm environment: Helm lint, Helm fetch, Helm get, Helm status. Well, you can read, I don't need to read it for you, but these are commands that you should be aware that they really help you figure out what's going on when you start having problems. I'll talk a bit about that later down the presentation. I'm assuming that most of you are familiar with Helm Hub. It's actually a hub that hosts or aggregates Helm charts from repositories of any contributor. If you have Helm charts and you want to contribute, there's a fairly simple process of contributing to it. And inside Helm Hub, I don't know how many, I think there are like 100 external repositories and probably thousands of charts. So it's a great place to start out and find anything that you need. Visibility. I think one of the biggest challenges, especially for me and also for my developers, I don't give you SSH to the server anymore. You need to find the tooling, how to get the information without the need to even use the kubectl. You need to be able to provide your teams with good monitoring, good logging, and good debugging tools. We use the simple stack of Prometheus, Grafana. Out of the box, their official Prometheus operator Helm charts is installed on most of our Kubernetes cluster. It just works. Visibility, I talked about before, the log collection. Again, we have the EFK stack, a bit of configuration, some tuning, and it works. Debugging, one of the biggest challenges is how to actually debug when the hits the fan. And that's where the tooling around is the one that you have to use. kubectl itself, I know you're aware of kubectl describe, I think is one of the most powerful commands because it really gives you a lot of information that you're easily able to overlook because you're already thinking, how do I SSH into this restarting container? Because you can't. So look into kubedescribe and its capabilities, getting the logs, kubectl exec, being able to remotely execute a command on your container, like output a content of a file, or run some process to trigger something inside the container, that assuming the container works. A great tool we've been using lately, the K9S, I hope you're familiar with it. If not, get familiarized with it. It gives you all of the capability of kubectl and dashboard all combined into a CLI tool. It uses your existing kubectl connection, and you don't need any special setup for it. And the guy developing and maintaining it is doing a great job also answering issues and taking care of problems when they arise. Related to Helm, we said before, use Helm template or use Helm debug dry run to actually generate the resource files and understand what did Helm understand that you didn't understand. Okay? That helps us many times to understand, oh yeah, we messed up some configuration value, or Helm resolved something because of a macro or because of a template differently than what we expected. So that's one of the ways to get the information. Helm get is always a great way to actually get these manifests in a Kubernetes resource or YAML format back to you, so what's actually deployed. And again, it helps you really understand what's going on. Use it with your CI. So this is an example of a Jenkins pipeline. I assume you're familiar with it. We used this last year to deploy actual environments of our products for customers trying out our product in different geographic locations around the world. So we had Australia, India, and US. These are actual sites. We used GKE regions for it, and this was all controlled with a single click of a Jenkins button using our Helm charts. And at the end of this execution, within about 20 minutes, you have all these applications running, configured, and ready to be used, ready to be tested. It was actually a great opportunity to test the latency and test the tolerance of geographically distant services. And last but not least, the community. I think one of the biggest assets of the Kubernetes is its community. Kubernetes itself and all of the other projects in the ecosystem have such an active community that if you're looking for a problem, it's most likely that someone else already had this problem. And if not, they're great places to get help. You open up a GitHub issue in a relevant GitHub repository, you always get a response. You always get an answer. And I've had great cooperation. I just give a couple of examples here. The RabbitMQ Helm chart. I found the author of the chart. I contacted him. He was very helpful. We were able to fix something. MongoDB Docker container was developed by Bitnami. We had an issue, and again, they were great. They really helped us out. So I'm here at the end. I'm recapping. Start small. Get the application ready. Think about security. Always think about security. Use the limits. Use the probes. The health probes are very powerful, very important. Visibility. It's probably the most important part with the abstraction of Kubernetes, and work with the community. I really think that's one of the most valuable assets here. I will be sharing these slides. Just follow the hashtag. You're welcome to see me at the JFrog booth for any more conversations or questions, and thank you very much for your time.